Good afternoon, ladies and gentlemen, and welcome back. Today we're going to be looking at chapters 10.6 and 10.7 today because they're both relatively short chapters. They concentrate on the volumes of various things, like we've seen volumes of cones, cylinders, pyramids, prisms, etc. We're going to be calculating the volume of several things. First bit up here, let's look at some volume formulas. For a prism, the basic formula is just going to be base area times height. All right? Take the base area of your prism, multiply that by your height, and that's going to give you your volume. Volume literally talks about how many cubic or how many cubes, unit cubes, could fit in a figure. So if you were to, let's say, start drawing some little miniature unit cubes fitting into that figure. Terrible drawing of a cube, but suppose you had several cubes fitting into that figure. This equation will give you how many cubes would fit in there. A cylinder is going to have the exact same equation. Only difference, base area for a cylinder is just pi times r squared, right? Pi times r squared. So our volume would just be pi r squared, multiply that by height. For pyramids and cones, there's a really cool fact that if you fill up a pyramid with water, all right, if you have a pyramid and a prism that are the same shape, except, obviously one's a pyramid, one's a prism, so they have the same base area, same height. If you fill it up with water, it'll take 4 of those pyramids to fill a prism. Similarly, it takes 4 cones to fill a cylinder. 3. Excuse me, did I say 4? I meant 3. There are 3 pyramids to fill a prism, 3 cones to fill a cylinder. So volume equation, that's still going to be base times height. We're going to divide that by 3. Similarly with cones, we're going to do pi times r squared times height, and then just divide that by 3. All right? So if we want to find the volume of this prism, let's say, this prism, well, we want to know the base area first. Looks like it's a triangle with base 9, height 5, so we'd say that that's base area is 1/2 times base times height. So that is 0.5 times 9 times 15. 0.5 times a 9 times a 15. Let's toss that into a calculator. This is 67.5. All right. So if we want volume now, that's going to be base area times height of the figure. This is a different height than the triangle's height. Triangle's height had to do with height of the triangle. Now we're looking at height of this prism, the 12. So we go and plug in 67.5, multiply that by 12. And that gives us a total of 810 yards cubed. We've done yards squared in the past to represent surface area or area. This is going to be a yards cubed. How many cubic things can fit into shape? For cylinders, you're going to do something very similar for this one. Volume is equal to, remember the equation, pi times radius squared, and then you're going to multiply that by the height of the thing. So that'd be pi times 9 or 14 squared times a 9. I know 14 squared is a 196 times a 9 gives us 1,764. Multiply that by a pi. We're going to get a grand total of, let's see here, 5,541.77 centimeters. You guessed it, cubed. Centimeters cubed. We did that just by plugging it into the formula. You can do the same type of thing with, let's say, a trapezoidal pyramid. We have a trapezoid base It's a pyramid. It's going off into the distance. All right. Well, here's what we're going to do with this. We're given that AE is perpendicular to ABC, so AE is shooting straight up. That's the height of our pyramid. All right. Volume is going to be base area times height. Let's find the base area first. Base area, if you remember from trapezoids, it's base 1 plus base 2, divide by 2, multiply that by a height. 9 plus an 18 is 27, divided by 2 is going to be 27, 13.5, multiply that by a 6 is a something. Let me take a calculator out real quick here. 9 plus 18 divided by 2 is 13.5 times a 6 would be an 81. Our base is 81 meters squared in area. Volume now is going to be our base area times our height, which is going to be that 81 multiplied by the 10. 81 multiplied by a 10, anything multiplied by a 10 is just going to be moving the decimal point over one place. So we'd say that's 810 meters cubed for our volume of this shape. For this last one here, cone, we have the height of it. We don't need the slant height for this. I know for surface area we did need the slant height. For cones volumes we do not. Instead, here's what we're going to do. We're going to go ahead and just, here we go. We're going to do volumes equal to pi times radius squared times our height. That'd give us the area if it were a cylinder. Just divide that by 3. All right. So pi times a radius of 9, 9 squared is an 18, times a 14, divide that by a 3. Pi and the divide by 3 almost cancel each other out, not quite. So I'll go and type in pi times an 81, times a 14, divide by a 3, gives us a grand total of 1,187.5 centimeters cubed overall for the volume of our cone. If you have any questions, as always, email me, let me know. I'd be glad to answer them. Assignment for tonight is in the book, section 10.6 and 10.7, getting some practice with these prisms, pyramids, cones, and cylinders volumes. Have a lovely day.